So my name is Miona Aleksic. I'm a product manager at Canonical. And together with two of my colleagues that are sitting over there, Katie and Simon, we will be talking about all things MicroCloud today. As you can see, the title of this talk is how you can build your own cloud and basically explore microclouds, specifically for homelab use cases, because we thought that might be interesting for the audience that comes to this conference. But MicroCloud is a production-grade product. We have customers using it for their production workload. So home labs is not the only things you can use it for. So the agenda for today is basically we'll talk very briefly about why should you have a home lab? Again, I imagine many of you already have it, but for those that don't and are thinking about having one, I'll just briefly cover what are some of the things you should consider when building your home lab. We will talk, of course, about what is MicroCloud and how can you use it in your home lab environment. We'll do a couple of demos and show some practical things you can do with MicroCloud, and then, of course, we'll leave some time for questions as well. So feel free to think about things you would want to know that we might not cover in the presentation. So I do imagine many of you do already have a home lab, but for those that don't and are maybe thinking about having one in addition to, of course, your laptop or your workstation, home labs can be super useful for development, learning, experimentation, simply because you can create something that has more resources, more flexibility, but you can also think about things like security and so on and create something that is really fun and that can really help you be more productive and do better work. You can use it also for cost-effective testing, simply because sometimes your laptop might not be enough for all the things you want to do. I know mine is not, so when I do things on a MicroCloud, I can do a lot of other cool things. And it simply gives you a lot of flexibility and control, so you can really tailor it to your own needs and do the things that you need to do. What are some of the things that you should consider before setting up a home lab? Well, obviously, hardware and equipment is probably the most important thing. And that goes kind of hand in hand with space that you have, because obviously you should pick hardware that can do the things that you want it to do. But depending on what kind of space you have, what kind of power you have, whether you need cooling or not, you might want to consider different things. And we'll give an example of something that we have done. Once you've selected your hardware, you need to think about software and virtualization that you would run so that you can access your infrastructure in an easy way. And that's really where MicroCloud comes in. You need to think about your network setup, especially if you're going to be running some risky things. You might want to isolate your lab from the other things you have running in your home network. And then you should think about security, data integrity, and probably having backups for some of the important things you might be running there. So enter MicroCloud. Why is MicroCloud really useful for this? We will be showcasing some of the practicalities a bit later, but I wanted to talk about some of the main benefits on why MicroCloud is really useful, particularly for a home lab use case. First and foremost, it's resource efficiency, because MicroCloud itself doesn't really consume much, which means that even if you run it on hardware that is not that beefy, you would have more resources left for your actual workloads, as opposed to what MicroCloud control plane needs to run itself. Deployment and operations are very simple, which is also something that is super nifty, because you would probably want to spend more time developing things as opposed to, maintaining the underlying infrastructure, which can be, sometimes very annoying. And then also MicroCloud itself has fairly low hardware requirements, which means that if right now you don't have resources to buy super beefy, super expensive hardware, but you have some older hardware that is lying around, you can still deploy MicroCloud on top, and it can still give you quite a lot for very little. So what exactly is MicroCloud? It's a lightweight open source cloud platform that is comprised of three main elements. It uses LXD as the virtualization layer, and then it combines it with software-defined storage and software-defined networking, so you can have highly available cloud that uses distributed storage and networking and can give you a lot of benefits because of that. What is different with MicroCloud than some of the other things is just the way that it's designed and the way that we are distributing these components. And Ken before was mentioning snaps. I'm going to mention snaps as well. I know it can be a controversial thing, but as Ken was also mentioning, like when we talk about infrastructure use cases, snaps can be super, super useful because they allow us to install things in a much easier way, but also to maintain things in a much easier way. Because With infrastructure stuff, you have a lot of dependencies. You have a lot of packages that you would need, a lot of things that your stuff might depend on. And by packaging each of these infrastructure components inside a snap, all of the dependencies are already there. So you don't need to think about it. You install the snap and it's ready to go. And that's really the reason why we call it MicroCloud and MicroCef and MicroVN. It's not because it's small, although it is, but it's because it has a low footprint, which means that you can really run it on a variety of devices without it being too problematic. So I want to take a moment just to talk about LexD. And out of curiosity, how many people here in the room have tried LexD before? Yeah, that's nice. So, well, I hope that those that haven't will try it after this. But it's basically an open source virtualization platform that has been developed by Canonical since 2015. It all started with system containers that were based on Aleksic or Linux containers, and that was our main focus for quite a while. And then over the years, we have also added support for KVM-based virtual machines, and then added a lot of different functionalities. We'll showcase some of them, but basically nowadays LexD has quite a lot of built-in management features that allow you to configure it in many different ways. And that's really the component that governs the interaction with storage and networking. So while the MicroCloud Snap kind of brings all of these components together, your main interface is really LexD, and that's what you would use to launch your workloads, to configure your networks, etc. We have been, since the beginning, following the Ubuntu release cadence, which means that we have LTS releases every 2 years that are released at the same time. So the previous one was released last year along with 2404. Next one is planned next year. And then we also do periodic feature releases, which would basically have the latest and greatest things that we have added. And those are probably the ones that are good to use for development use cases because they would have the newest things. In terms of the way you can interact with it, it has a web UI, which we will showcase a bit later. Of course, you can use the CLI, which we will also be showcasing during our demos. And of course, everything is REST API based, so you can integrate it with any tools you might be using. We have a Terraform provider, for example, so if you want to use infrastructure as code, you can do that too. I do want to spend just 1 minute also talking about system containers because this is not something that everyone is aware of. Because we know containers, but usually when we say containers, we think about OCI containers. We don't think about system containers, and they're a little bit different. So the two main type of workloads we see nowadays are either, as I said, OCI containers, which kind of give you an application or a process in terms of the isolation of the thing you get to work with. And they're a very light footprint because they utilize the kernel of the host, so you don't have the overhead of virtualization and so on. And then, of course, we have virtual machines on the other side that give you a full system, but they have a heavy footprint because they virtualize another kernel. System containers actually kind of have the best of both worlds because they have the light footprint, they utilize the kernel of the host, there's no virtualization involved, but they give you a full operating system, which means that you can use it in the same way you would use a virtual machine. You can install things, launch things, but you can do that in a much more lightweight way, which, well, for a home lab use case, it's particularly useful. Important thing to mention when it comes to specifically system containers and the way LexD provides them is that we are providing unprivileged containers by default, which means that you don't have access to certain parts of your system that OCI's containers do. You can allow privileges if you need to, but that's something that you opt in if you want to. So by default, it's more secure and it doesn't allow you to access some of the more privileged things. So what are some of the practical use cases that you could use MicroCloud in a home lab setting? Well, you can use it for software development. Of course, you can use system containers as reproducible development environments where you can test different versions of your software or run locally hosted software in an isolated and a secure manner. You can use it for your personal cloud, simply to have a cloud environment where you can do things like host media servers or Minecraft servers or file shares or things like that. You can use it for more complex things like simulating a distributed system or using containers for databases, web servers, things like that, so you can kind of use it to play around or to run and learn cloud native things as well. And then probably some of the things that most users usually struggle with is networking. So if you're on MicroCloud, you can actually practice networking. So you can test different network configurations, you can simulate multi-cloud environments, you can implement firewalls, and do that all in kind of a secure and controlled and isolated environment without messing up the rest of your things that you might be running. So let's talk about an example MicroCloud setup. And here we have this box that unfortunately is not working. Because it came all the way from Sweden and something moved inside of it while it was on these long flights from Europe all the way here. But it did work just before I left for US. So I do promise it does usually work. But this is basically a small demo box that we designed about a year and a half ago when we were launching MicroCloud. We wanted to have something that is small but powerful, that is portable, that we can kind of put in a sports bag and take around on the conferences and so on. And have it work, usually. But either way, so what's inside this specific MicroCloud box? So we have been using these Odroid motherboards. For those that are not familiar, Odroid is a Korean manufacturer that does this pretty powerful boards that you can customize in a lot of different ways. Each of these motherboards has 16 gigabits of RAM. It has 2 external disks, an SSD and an NVMe SATA disk. One is used for local storage, one is used for distributed storage. Of course, we have some cables. We have a router so that we can figure out the networking. And then for the enclosure, we are using a Pico cluster enclosure. This was just an easy thing for us to get because it's kind of designed to support these boards. It includes a switch, a power, and a fan, so all of it kind of comes together. And we did a little bit of do-it-yourself type of thing because this enclosure is actually designed for 6 boards, but we have 3, and then we're using the other half to host the extra disks and stuff because otherwise there would be no space. So it worked pretty well for us until today when we tried to turn it on here. Also, I mean, we built this, as I said, about a year and a half ago. Back then, everything together costed about $2,000 US. You can, of course, go cheaper, you can go more expensive. There are many different things. This is just something that we chose at that point. And then, what does setting up a MicroCloud actually looks like? So, once we got all this hardware, we built the box. We actually burned the switch when we were building the box because we used the wrong cable, but we were able to work around it a bit later. We installed Ubuntu Server on all of these boards, but you could also install Ubuntu Core if you really want to run it in a even more lightweight way. And then everything you need to do is basically install all the relevant snaps on each of the systems, and then you need to run MicroCloud init on one of them, and MicroCloud join on others. What will happen later is that MicroCloud will kind of reach out to all of these systems. It will recognize what's there. It will recognize all the various devices that are there. And then it will ask you a series of questions. We'll be demoing that in a second. But basically, it will ask you if you want to set up local storage, if you want to set up distributed storage, if you want to encrypt your disks, if you want to set up dedicated networks for a variety of things. But it's really just an interactive CLI where you answer some questions. And then once you answer the questions, it just configures everything on its own, so you don't really need to do any of it. So you can have a fully functional cloud up and running in a matter of minutes. Once it's deployed, this is more or less what is running there. So each of these nodes, it's having local storage. It has, as I said, a disk for distributed storage, and then MicroSAF is spread across the entire cluster, which means that it gives you data redundancy, and if one of the machines goes down, all of the data is still there and you can move workloads around. LXD is also deployed across the whole cluster, and same with networking. So I've been talking a lot, so maybe it's better if we actually see these things in action. So I will hand it over to my colleagues and they will explain some of the things. We were lucky enough that we did pre-recorded demos. Hopefully you can see them enough on the screen. In case you don't, come talk to us later and we can show you more directly, and then you can see some of the details you might not be able to notice right now. So Simon, take it away.
Thank you, Miona.
So they are uploaded on YouTube. They are currently unlisted, but I suppose we can just write the description in the box and then I also list them. So they're around, and we can also share the slides for those that are interested.
So it should be loading eventually.
So I plugged in the Ethernet cable, so it should work a bit better, but maybe it doesn't, so
No,
let's see. Yeah.
it's coming. All right, so let's first start with what we have. So in this demo, we're going to initialize a MicroCloud made up of 3 virtual machines. We've been using virtual machine just for the sake of the demo because it's the exact same process if you were to do it on physical machines. Wow, that's okay. So here we have 4 terminals. Top left is some network information that will be used to provision oven, and the other 3 terminals are root shells on the 3 machines that we will be clustering together. We see that all 3 machines have the same set of snaps already installed, so that MicroCloud is able to do its job. So. Is that, well, the resolution is still crappy, right? It doesn't get any better, though.
We'll have this at the booth later, so you can also pass by and we can just rerun these videos. They're pretty short, but yeah, hopefully you can at least understand what's going on. Cannot switch off, turn off the light.
Well, problem is...
I'm trying to find out. I'm a software guy. Hey!
Thank you. There you go. All right, so we've picked Micro 1 to be the initialization node. So we run MicroCloud in it, and the first question it asks is if we want to create a single node microcluster, which is a viable option. But in that demo, we decided to not go with that option and instead go with multiple nodes. So it asks which network to use for discovering all of those other nodes. And after that, it provides you with a passphrase that is randomly generated for that joining session. And that passphrase is meant to be easily typable and memorable. So if you have to run around in your data center and type it on multiple machines, it should be easy for you to do so. So once you've provided that shared passphrase, there you go, text is crisp now. So once you've typed that passphrase onto your joining nodes, they will show up as available candidates to onboard onto your cloud. And once you've selected them, you will be provided with a list of all of the disks that they come with, and you select which you'd like to use for local storage through ZFS, and if you have any left, you can use them for remote storage through Ceph, and you will then gain highly available storage. The highly available storage is entirely optional. You're free to not use it, and you will still have a MicroCloud functional, just minus the HA storage. So here we see that we were also asked if we wanted to add a dedicated network for Oven, which we did, and we're feeding configuration options so that Oven can provide internet connectivity to our workloads. So once MicroCloud has all of those answers, it's able to go around and configure all of the individual components like MicroCeph, MicroOven, and LexD, and cluster them together. And in the LexD case, it also makes sure to create a profile that by default will have your instance backed by the remote storage, which is highly available thanks to Ceph, and the distributed network thanks to Oven. And yeah, once it's done setting up those daemons in a clustered fashion, you are able to interrogate each of those and run their status command and report of their individual member health. And you can also run the MicroCloud status and get a meta overview of all of those daemons and the cluster itself. And once the microcluster reports as all healthy nodes, you're able to interact with your cloud through the Aleksic commands and then launch instances however you like. So we see the MicroCloud status is all green.
Before you move on to the next demo, I just wanted to mention, because we've done quite a lot of testing on this. So deploying a 3-node microcloud takes about, well, you saw maybe 2-3 minutes. If you want to run a bigger cluster of, let's say, 20-ish nodes, it takes about maybe 5 to 7 minutes. So again, like, you can very, very easily, as long as you have your machines ready, provisioned with an operating system, you can simply provision your cloud in a matter of minutes and have it up and running. And you can do it in a repeatable way. So every time you do it, it will look the same, it will behave the same. And also we do support doing this via pre-seed files. So if you don't want to do the interactive mode, you can just basically create a YAML file with all of these answers and then just feed it to each of the machines, and then MicroCloud will be ready to go.
Thank you, indeed. So now that you have your MicroCloud up and running, let's see how you can benefit from the highly available feature that you gain from it. So in that demo, what we have is the same MicroCloud made out of Micro 1, 2, and 3, and it's powering 4 instances. So 3 LLM nodes, one running off of each of the Micro 1, 2, and 3, and we also have a virtual machine, which is called V1, running out of Micro 3. The virtual machine is configured in a way that whenever the host powering it undergoes maintenance, it's going to be live migrated to another machine, while the LLM nodes, since they're working all together to provide a highly available service, they will go down along with their powering host. So they're not configured to be migrated away. So we also have the terminal in the middle, where we have a repeated query to the LLM service, responding to the same question, but we see who responds to the question, which LLM node provided the answer. And here we're going to simulate some maintenance that we need to do on the Micro 3 machine. So we start by listing all of the cluster members, 1, 2, and 3. They're all operational. And since we want to evacuate Micro 3 so that we move the VM away, and we cleanly shut down LLM node 3, so it will be removed from the rotation of the LLM answers, but the service will still remain available because the other nodes are picking up the slack. And once we've evacuated, we can do the whatever maintenance we needed to do on it, whether powering it off, add some memory, or change the disk, or whatever, bring it back on. And when it's powering back on, all of the daemons that are part of the cloud, like Ceph, Oven, and LexD, will reestablish connection with their counterparts on other cluster members. And once they will all be functional again, we will be able to restore the node into the cluster, at which point the instance it was powering that was stopped cleanly will be powered back again, and the VM that was live migrated away from that node will be brought back into onto that physical machine. So it takes a few minutes, so let's fast forward because there's no point in waiting for it. So it's currently being restored. So we see that LLM node 3 is powered back again, and it will join back the prompt rotation. And the V1 virtual machine is moved again, and we will see that its uptime is over 2 hours. So it was never powered down, despite having the initial powering host undergo power maintenance. And that's it.
Thank you, Simone. So now that we have a deployed MicroCloud, we're going to kind of continue with that deployment. And one of my favorite ways to use MicroCloud is for reproducible developer environments. So we're going to use the LXD CLI and LXD profiles to define a pretty simple Go developer environment. So just opening up this YAML file. So LXD profiles allow you to declaratively define what you want your instances to look like. So you can use Cloud Init by passing in Cloud Init YAML into the user data config key. So here I'm just adding some basic packages, installing the Golang snap, setting up some users, and setting up my Go path. And further down in the file, we have our device configuration. So here I'm just passing through a network device, which is using the LXD bridge network. And I'm also mounting a path for my home directory into the instance and setting up the root directory with just our default storage pool. Okay, so I'm just going to create a LXD profile by passing in that YAML file. And then we can launch an instance. I'm going to use the Ubuntu Noble image, call it DevBox, set some limits. We're going to give it 1 virtual CPU and 1 GB of memory. And pass in that profile. And because system containers are pretty lightweight, it's going to launch very fast. And I had already previously downloaded the Noble Ubuntu image. While we wait for Cloud Init, I just want to talk a bit more about LXD profiles. So we can declaratively define what we want instances to look like, not just using Cloud Init, but also specifying devices. So we have the ability to pass through GPU devices, storage devices, set up network configurations, and these profiles can be applied to system containers and virtual machines. Yeah. Yes, you can. Okay, once Cloud Init is done, we can execute commands using LXD, or we could also drop a shell. In this case, I'm just grabbing the Go version. Another popular use case for MicroCloud is, let's say you have a production cloud on one of the public cloud providers, AWS, Azure, or Google Cloud. You can also use MicroCloud to simulate cloud environments. So you can simulate launching cloud type instances and run your workloads there before moving them into production. So this demo just briefly demonstrates that. Apologies for the smaller font here, but I'm just again using the LXD CLI to initialize a Noble Ubuntu instance, and we can specify the type by using the type flag prefixed with the cloud provider, so AWS, and then after the colon I have the type, which is the T2 Micro, and I also launched a T2 Nano, and these basically just define some hardware specifications. So we have the ability to deploy as many of these instances as we want, matching our cloud provider specifications, and we can launch system containers or virtual machines. So far we've been interacting with our MicroCloud using the LXD CLI, but we do also have a web user interface, so I'll now pass it over to Miona to show you guys that.
And I think now you can turn on the light. We won't be showing any more terminals. So if I was showing MicroCloud on this box, it would say MicroCloud, it would have 3 systems and so on, but given that the box is not working, I'm just going to be showing you my local XD, but it looks very similar. It's just right now, this is just a single instance, it's not a cluster, so I cannot do some of the things, I cannot do live migration and so on. But I just wanted to briefly show it because maybe some of the people here are more like to click and point as opposed to use the CLI. I doubt that's the case, but still this can be useful for some. So this is really what LXD looks like. So in terms of the way work is organized, we have projects. So here on the side, you can see I only have two. I have the default one and a testing one, and I can create as many projects as I like. So if you're using MicroCloud in like a team environment, you can really use projects for multi-tenancy coupled with fine-grained access control so that you can define this project for this team or this person, and then really specify the kind of things that they are allowed to do. So you can set up a resource limit, you can designate specific networks, etc. So you can really kind of slice and dice your MicroCloud as you see fit. I won't be doing too many of these things because, as you can see, network is horrible, and this VM has been loading for like an hour. So either way, if you go to create an instance, you have several different options. You can browse images that we provide, and I'll show those in a second. But you can also upload custom ISOs. So for example, if you wanted to launch a Windows VM, this is what you would use. Or you can also upload an instance file. So for example, if you want to upload a VMDK from elsewhere, you can use this and just upload your VM, convert it, and have it ready to go. But we do provide a library of Linux images for your convenience. Of course, we have the Ubuntu images, but we also have others. We have OpenSUSE images. Where is our OpenSUSE friend? Here they are, somewhere on the bottom. Here they are. And we have a variety of images. So we actually have cloud, desktop, and the default images. So for example, for desktop images, this is actually what I was trying to launch before that is stuck on loading on 50%. But we have desktop images so that you can launch and basically almost use it as a VDI because it can give you access to a desktop machine. Again, we do have those also for Arch and for SUSE. So you can test those out. Anyhow, once you choose your image, and I will just choose this one because it's cached already and it won't need to download things over the network. You can apply a variety of configurations here, so you can specify disk, network, and so on. I won't be doing that at this point. But if you do have a profile, like Kaden was showing before, which I don't here, I did on this box, you could just apply that profile. So all the configuration that he had specified and all the cloud init stuff, it would be automatically applied. But you can also do that directly here. So if you go to cloud init, you can kind of add the things you want to do. And then once you're ready, you just do create and start. And then it should take a few seconds for it to be up and running. Once your instance is ready, you can see a bunch of things here. You can change the configuration, apply a bunch of things, access the terminal from the UI. You see a migrate button here, but in this case, this migrate button won't be a live migration button because it's on, again, only one single node. But it will show you that you can move this instance to a different storage pool or to a different project. And again, if I had additional cluster members, if this were to be clustered, you would have another option there that will tell you move this instance to another cluster member. Here you have a variety of options. Again, I won't go through all of them, but basically you can, all of the things that you can do in the CLI that we have shown in the previous demos, you can do them in the UI in a very, very easy way. So let me move back to the slides. There are some questions. Who has the mic, Jason, so that we can, so everybody can hear what you're asking? So yeah, I cannot I cannot demo this here because again we don't have the full setup up and running, unfortunately. But you can do snapshots of an instance. Let me see if maybe I can do that, and you can export also things as a backup. So it's backing up, but it won't really work that well. And as we speak, we're actually working on an option to basically copy instances, or rather copy snapshots from one cluster to another, so that you can kind of set that at a certain rate and then have it done incrementally when needed.
Yeah, one more question. So for like S3
Yes.
storage?
So Ceph, why Ceph is cool is because it has block, file, and object storage all in one. So it's for backups, not yet, but it's on the roadmap. Yes.
Do you have an enterprise version?
Well, everything we do in Canonical is open source, so there is one version that is limitless. So we don't have an open source version and an enterprise version. This is the enterprise version. I think I mentioned at the beginning, we have several customers running it in production. We have a couple of government institutions. So the only thing that you need to do, so you can deploy it yourself if you want to. We do have services to deploy it for you. And then the only thing that you would need to do is just get Ubuntu Pro so that you can get access to our support and then call us if something goes wrong. But yeah, there's no licensing involved. It's all open source and available. There is no gatekeeping of any features. Yes, so that's Ubuntu Pro. So with Ubuntu Pro, you basically pay per machine per year, and then you get 24/7 support. We support not just the infrastructure, but any open source packages you might be consuming from our repositories. So it's pretty nifty because you could have MicroCloud, you could have the data science stack that Ken was showing before running on top, you could have some databases, and all of that would be covered under one Ubuntu Pro support, which you can see pricing online, but it's transparent. And as I said, it's per machine per year, so it doesn't matter how many cores you have, how many sockets, it's always the same. Yes, so yes, it gives you kernel live patch. It gives you access to landscape, for example, that allows you to manage your machines. It gives you access to hardening tools. So we have sys hardening and disastig and FIPS and all of those things. So you can really use it to secure your whole stack, and then also, again, have someone to call if something goes wrong. We have managed services as well. So if you're interested in anything, just let us know. We can give you more details.
Sorry, for loading images, can you also load Ubuntu Core images?
Yes, we do. Let me see if I can show it here, because I don't know if I added that particular remote here. No, I didn't. We do have also Ubuntu Core remote, I think in the 6 for VMs, yeah. We do, and you can run them.
All right, we have another question. I'll get you over here, and then I'll come to you.
Let me do. I can skip the summary and just leave this.
What operating systems can you run MicroCloud with?
Sorry, can you repeat?
What distros of Linux can you run MicroCloud with?
So, I mean, we run it on Ubuntu, and we support it on Ubuntu, but technically you should be able to run it on any Linux version that supports snaps, because these components are distributed as snaps. So as long as it supports snaps, you should be able to run it. But as I said, we develop, test, and support it only on Ubuntu, so if you want extra assurance from us, run it on Ubuntu.
All right.
Maybe one thing that I actually didn't mention, I think, when I was talking, is that MicroCloud works on both Ubuntu Server and Ubuntu Core, so that's also pretty nifty.
Coming from the world of Proxmox, when you mentioned 3-node cluster in your demo here, when you're in Proxmox and you do multi-node cluster, there's a mechanism to avoid split brain called quorum. I'm curious, is there a similar mechanism here? Because if I had a 2-node cluster, I can't achieve quorum, and then you have some things happen.
Yes, so that's the thing. So MicroCloud does start from a single node. However, if you run it with 1 or 2 nodes, then we don't consider it highly available exactly for these reasons. So HA starts at 3 nodes. We use Raft algorithm to kind of achieve quorum and to have voters and then the database leaders. So you need a minimum of 3 to have this kind of redundancy and high availability and to make it reliable.
Hi, apologies if you answered this earlier. I was a little late, but
Just
how
shoot.
could this differ from like just an enterprise hyperconverged infrastructure where you're using a traditional KVM hypervisor?
It doesn't really. This is exactly what it is. So it's an open source hyperconverged cloud platform. What is cool about it is simply that it's a bit more efficient, a bit more optimized, because oftentimes, I mean, you know, we've been dealing with cloud over decades, and we've been kind of adding things, and you have a lot of moving pieces. What we wanted to do with MicroCloud is kind of optimize it a bit, remove some of the unnecessary pieces, and then make it operationally easier, which is why you technically have only 3 components, but they still give you quite a lot of things. But it's exactly what it is. It's a hyperconverged virtualized platform, and you can use it for anything you would, any kind of enterprise-grade platform that has been around for a while.
And then does it support Kubernetes as well?
So we would run Kubernetes inside virtual machines on top. So we are currently adding some of the foundational things that will allow us to eventually do have also Kubernetes as a service, but we won't run them on bare metal. They would always be kind of loaded in a cluster of VMs, and then you can kind of manage it how you usually would. Other questions?
Any more questions?
So feel free, like there is one more here.
Get my steps.
The UI that it showed, that only runs on the main plane instance?
So no, you can access it from any cluster member. You do need to set it up. I mean, what I have done here locally, there are two ways that you can set up the UI. You can authenticate it using a browser certificate, or you can do so if you have an OIDC provider. So mine is just run locally via this browser certificate. But if you have an OIDC provider, then you can set up a proper like single sign-on. You can access it from any cluster member. You can assign permissions as well. I cannot show that because I don't run it with OIDC, but you can do quite a lot of things.
All right, good questions.
One thing that I do want to mention, because I think we might have some community members from like our other versions. So we do provide quite a lot of images. We don't have every single option of the ones that are there. So if you're working with any of the other sister distributions and you would like to help us get your images here, we would gladly do that so that users that run LXD can run any of the versions, and we can provide them with images so they can do that in an easy way. So we can have a chat later if you're working on one of the other distributions. Cool. Then if we don't have any more questions, I just want to thank you for your attention. We will be around for the whole conference. We will be later at the booth, so just come and have a chat with us. If you have any specific, super tricky questions, we can try and answer those as well. So thank you very much.